Hello, I'm Jeremy Singer from the University of Glasgow in Scotland, and I want to talk to you about Jupyter notebooks. The planet Jupiter is the largest planet in our solar system, and it's also the subject of a movement from Holst's Planet Suite, which is subtitled The Bringer of Jollity. Project Jupyter began in 2014 as an open source movement, and initially it was a portmanteau of Julia, Python and R programming languages. Jupyter. It's an interactive notebook code environment which is now gaining a massive open source following. I'd like us to consider the evolution of developer tooling. So, back in the 1970s and 80s, we all used text editors, a bit like this Emacs buffer here. In the 90s and the 2000s, we moved on to integrated development environments, like Visual Studio and so on. But really, nowadays, in the past 5 years or so, we've moved on to interactive computational notebooks like the Jupyter system here. You can see how the affordances of technology have influenced the different coding environments. So when we just had TTY terminals, we had to use text editors. When we progressed to more complex windowing systems with GUIs, we could use IDEs. And now we have responsive web applications, we can use notebooks. Notebooks are definitely popular. So the GitHub online portal for open source code natively supports the IPYNB notebook file format, and apparently there are around about 10 million notebooks on GitHub. A little bit about the architecture of the Jupyter system. So a user is interacting via a web client, and this renders the view of the notebook on their web browser, which is served by a Jupyter web server, possibly Jupyter Notebook, Jupyter Hub, Jupyter Lab, and this server here may be running on the same machine as the client. There are two other components to the back end. One is the programming language kernel, which is the interactive interpreter that's responsible for executing the fragments of code contained in the notebook as invoked by the user. And the other part is the notebook file store, which persists notebook data in this JSON format, IPYNB. It's certainly the case that novice coders enjoy using notebooks. I know this from first hand because at Glasgow University in Scotland we've recently been running a massive open online course called Getting Started with Teaching Data Science in Schools. And this course, which received positive feedback from the learners, was deployed using a notebook system. It's also the case that expert scientists like notebook. Here's an article from Nature, Why Jupyter is Data Scientists' Computational Notebook of Choice. And from astronomy to zoology, scientists of all flavours are using Python, largely, other languages too, but within a notebook coding framework. Notebooks are shareable between scientists. Notebooks are portable between systems. Notebooks are publishable as artifacts, so the arguments go. Let's explore where the notebook concept originated. I think we need to go back to Donald Knuth, who pioneered the notion of literate programming. The idea here is that source code is interspersed with human readable commentary in a unified document. Notebooks preserve this notion of a unified document because notebooks contain both human readable markdown and executable code. A literate program is a static artifact. It's just a textual document in that sense, with different marked up sections. On the other hand, when we move on to the innovations of Stephen Wolfram and the Mathematica system, we come on to the first inklings of interactive documents. So here we have the human readable commentary and the computer interpretable source code, and the source code is interactive. It's possible to execute the source code within the context of the document and see results in line. Finally, I want to draw your attention to Jimmy Wales and the wonderful contributions of Wikipedia. And the idea here, I suppose, is that we're crowdsourcing knowledge, that the encyclopedia itself is not read-only, but rather users can contribute to it. And again, I think this taps into the democratization of knowledge gathering and knowledge curation, which we see embodied in the Jupyter interactive notebook movement. Notebooks are user-friendly, I claim, as do its advocates. What I've got here are some comments which were taken verbatim from a focus group. These were the students who took our Getting Started with Teaching Data Science MOOC at Glasgow University. Some students highlight the exploratory, prototypical notebook features. They're good for playing around, good for having a go. And the idea here is that, notebooks are very malleable media, and you can edit them and interact with them and explore and experiment. Other people talk about the support and the comfort they feel from having the human readable markdown, the instructions, the commentary inlined with the code. One learner said, "You explain what will happen in each section." And I suppose that high-level summary that would provide understanding before or after source code execution is important for novice learners. Another user brought these two things together and told us that they enjoyed both the interactivity and the support in notebooks. And a final user said, "I really do like the simplicity. The fact that in a single web page they could create code and document code and execute code and inspect the results." I think the Jupyter Notebooks movement is really channeling the spirit of the age here. We're used to Googling and Stack Overflowing to find a fragment of code that we can borrow. And this copy and paste coding endeavour is really facilitated by notebooks, where code is split up into small box-sized units of maybe some tens of lines that can be copied and pasted very easily. Notebooks also tap into the bring your own device, BYOD philosophy. And here the idea is that anybody can code with any kind of computational device that supports a web browser. Let's talk about the structure of notebooks now. And I'd like us first of all to understand that a notebook is a linear sequence of cells. Unlike a spreadsheet, where the cells are located in a two-dimensional grid, here we only have a vertical sequence of cells laid out for us in our browser tab. Cells come in 3 different flavors. We have markdown cells, we have source code elements or cells in our notebook, and the notebook metadata itself encodes the language in which this source code appears, which allows us to do nice syntax highlighting and formatting, sometimes an element of code completion, and also connecting this source code to a back-end interpreter. There is a third kind of cell, which is the output cell, and this displays the result computed by the notebook. There's an output cell associated with each source code cell. Additional metadata is encoded into the notebook, including a count of the executions of each code block and the order in which those executions might have occurred. I want to get on to the meat of the talk now and tell you about problems with notebooks. The first problem I draw your attention to is the overwhelming nature of the user interface. Look, here's a Jupyter window here, which would appear inside a web browser, and you can see that there are 3 toolbar lines at the top. So if we were to assess this with something like the Cognitive Dimensions of Notations framework, we'd see that there's a steep abstraction gradient here. We'd notice that there's a large variety of tools and interfaces, and it's not always clear precisely where to go to accomplish particular tasks. In our online MOOC, Teaching Data Science, we used a cut-down notebook environment. So we dispensed with the menu bar and only had a single toolbar with some icon representations for very standard, most frequent user operations. One expects, as a coder, that code is going to execute from the top to the bottom. So here this looks like a sequence of 2 assignment statements to the same variable and then a conditional test on that variable. But because these are in separate code cells, execution order can be threaded through the cells in a different way. So we see here I execute the middle cell, the assignment of -1 to x first, then the top cell, then the bottom. And this means it will print out this is the answer to everything. Partial persistence causes problems too. So here the idea is that when you save a notebook and come back to it later, it preserves the output of cells that had been executed on a previous instance of the notebook, but the kernel doesn't preserve their state. So I've reloaded a notebook here and it's told me that I've executed these 2 cells and it shows me the output, but then I've executed a cell again, remembering this is a fresh instance of the notebook here that I've loaded. It says the name X is not defined, because although I see client side the state of the output from previous notebook executions, server side that state hasn't been accumulated or built up, and so X isn't bound to a name here. There are more interesting challenges for notebooks, as well as those ones which have been widely criticised and commented upon. I want to introduce 4 more interesting challenges here, and I suppose really throw down the gauntlet to people and say that we need to fix these problems if notebook coding is going to become more mainstream. There's no modularity. So in Python, very often the first thing you do is find an interesting library and import it. Well, you can't import a notebook. And indeed, the way in which libraries are modularized as functions and data structures doesn't necessarily tie in with the way that notebooks are structured in terms of code cells. Suppose you want to fork a notebook to execute in parallel with another notebook. Again, it's difficult to do that. There are certain hooks for parallel frameworks like MPI and so on, but again, these aren't straightforward to use. Versioning's a problem as well. Suppose you want to look at the textual differences between two notebooks. Well, normally you'd use the diff tool, and if you'd integrate this with something like Git, you could merge changes and so on. But of course, although notebooks are textual, in this JSON format, really there's a lot more text involved apart from just the text of the source code. Every source code management tool we used for textual source code in the olden days will have to be JSONified and improved for this notebook format. I think the most interesting challenge, which I'm addressing in my research group at the moment, is the idea of notebook introspection. So reflecting on a notebook from within that notebook. In the same way that an HTML document has a document object model that can be queried and updated through JavaScript inside that web page. In the same way that a Java program has a runtime class hierarchy that can be inspected and modified through the Java reflection libraries, we want notebooks to be able to introspect themselves and update themselves. Great, those are all the challenges. I think in conclusion I'm going to say notebooks are here to stay, but we need much better tool chains and frameworks to deal with notebooks. So maybe we're not joyful at the moment, possibly a little bit confused, possibly a little bit frustrated, but I think there are better things on the horizon. Thank you.